Alright, today we're looking at choosing a factoring method. We're going to jump right into example 1. And the point of example 1 is we are going to tell whether each expression is completely factored. And if it's not, we are going to factor it. So, first, we are going to look at two expressions. The first one, we'll call this example 1a, is going to look like 2x times x squared plus 4. Now when I look at this, I know 2x, that can't factor more because that is a monomial. And then I look at the second part, x squared plus 4. It looks very similar to what we talked about last time with two terms, both of them being perfect squares, but it's not a difference of squares. So what we say about this first example, we say this expression is not factorable. Or not that we say it's not factorable. What we can say is it is completely factored. Which kind of means the same thing. It means we can't factor it anymore. Let's look at 1b, where we're going to look at the expression 2x plus 6 times x plus 5. Well, I look at the first set of parentheses, and I notice right away those two terms, the 2x and the 6, are both divisible by 2. So I'm going to start by taking a 2 out of that term, a greatest common factor, and what would be left? If we took 2x divided by 2, we'd have an x. If we took 6 divided by 2, we'd have plus 3. And then that second expression, there's nothing we can take out, so it's just going to be x plus 5. So 2 times x plus 3 times x plus 5, that's it. Example 1b, done. Example 1, done. Now I've got some steps I want to show you for factoring polynomials. The first step we're going to do is check for a greatest common factor. We're going to look for a GCF. Then we're going to check for a pattern that fits the difference of two squares or a perfect square trinomial. Then, to factor a polynomial that looks like ax squared plus bx plus c, remember we're going to look for two numbers that add to make b and multiply to make c. And if they throw an a in front of x squared, so if we get ax squared plus bx plus c, we're going to use that AC slide method we talked about a couple videos ago. And then lastly, we're going to check for common factors. We're going to see, are there any repeated factors? If we look in different sets of terms, is there something that those sets of terms have in common at the end? Once we've done all that, we've factored our polynomial completely. So now I want to look at example 2, which what we're going to do in example 2 is we're going to factor the expression negative 2xy squared plus 16xy minus 32x completely. Now the first thing we do is we look, what do all three terms have in common? Well, I see they all have an x, so we're going to factor that out. I also see they're all divisible by 2, so we're going to factor that out. And then we also, in class, talked about how if our first term is negative, we can factor that out, and that's just going to change the sign of every term. So that means the first thing we're factoring out is negative 2x. What we're left with then is when we divide each term by negative 2x. So in the first term, we're going to be left with a y squared we're going to change the sign. So instead of having plus, we're going to have minus. 16 divided by 2 is 8. The x is gone, so we're left with a y. Again, we're going to change the sign. Plus, 32 divided by 2 is 16. The x is gone. So now we're not done factoring. We can still factor this y squared minus 8x plus 16. And remember, in step 2, we look for a pattern that fits a difference of two squares. Difference of two squares meaning if it's a squared minus b squared. We don't have that because there's a middle term. So difference of squares, that option is gone. Then we check, does this look like a squared minus or plus 2ab plus b squared? So can we write this as a squared? In this case, a would be our y. So we've got y squared. B, in this case, what number times itself makes 16? Well, that's 4. So we've got 4 squared. Now we just check. If we go 2 times y times 4, does that make 8y? The answer is yes. So we've got a perfect square trinomial. That means this is going to factor to a. We take the middle sign, so minus b, and we square it. So to factor this completely, our answer is going to be our negative 2x we factored as a GCF times a this time is y. Our middle sign is minus. B this time is 4. And we square that binomial. So negative 2x times y minus 4 squared. So now I want to look at example 3, which again, we're going to factor the polynomials completely, but we're going to utilize some of the methods we learned in earlier discussions. So 3a, we're going to look at 2x squared plus 5x plus 4. So I look at this and I don't see anything that's a greatest common factor. Not all of the terms are divisible by the same thing. But it does look like step 3, the ax squared plus bx plus c. I'm going to check the AC slide. So if I go 2 times 4, I get 8. So I want numbers that multiply to make 8, but they add to make 5. Well, numbers that multiply to make 8, you've got 1 and 8, and you've got 2 and 4. Since we have a plus at the back, we want both terms to be the same, both positive or both negative. 1 plus 8 makes 9, which is not 5. And 2 plus 4, if we add them, that makes 6, which again is not 5. So in this case, what we say is 2x squared plus 5x plus 4 is not factorable. There's no possible way to factor that. Let's look at 3b. We're going to have 3n to the 4th minus 15n to the 3rd plus 12n squared. Now I do notice something. There is a greatest common factor. Each term has an n. In fact, they all have n squared. So we're going to factor that out for sure. I also look at 3, 15, and 12 and know that all three of those are divisible by 3. So we're going to factor out a 3n squared. So we're going to write 3n squared. When we factor that out, it's like dividing every term by that. So we're going to have an n squared left from that first term minus a 5n from the second term plus a 4 from the last term. So when we're factoring this, we're asking ourselves now, what numbers multiply to make 4 and add to make negative 5? Since we've got a positive at the end, we want both factors to be the same, both positive, both negative. So numbers I know that multiply to make 4, we've got 1, 4, and 2, and 2. So we can use that AC slide method in a way like this as well. If we go 1 plus 4, that makes 5, and 2 plus 2 makes 4. We want the 5. So since both have to be the same, we're going to use the middle sign like we learned in our little tricks in earlier videos. Middle sign is a minus. So we're going to have 3n squared times n minus 1 times n minus 4. We're done with 3b. I've got 2 more left, and then I'm going to give you a table of different ways to factor. So 3, if we want to call it example 3, still we're on C, we want to factor the expression 4x cubed plus 18x squared plus 20x. Well, I see every term has an x, so we're going to factor that out. I also notice 4, 18, and 20 are all divisible by 2, so I'm going to divide or factor out a 2x. So we'll have 2x times what's left with the first term. We're going to have 2x squared. In the second term, we're going to be left with a 9x and a plus 10. Now, we're going to utilize our AC slide. We're going to go 2 times 10, 20. So we want numbers that multiply to 20 and add to make a positive 9. Since we have a plus at the back, our two factors should both be positive or negative. We'll check which is which in a second. So numbers that I know multiply to make 20, we've got 1 and 20. We've got 2 and 10 and 4 and 5. I want to see which ones, when I add them together, make 9. 20 and 1 make 21. That is not 9, so we don't want that. 2 and 10, that's 12. Still not 9. 4 and 5, that's 9. That's what we want. So when we're factoring this, we're going to have 2x. We have to bring that common factor all the way through. Since that's a plus at the back, we're going to take the middle sign in our factors. We're going to have an x plus 4 and an x plus 5. Since there's nothing in common, we're done. We've got 2x times x plus 4 times x plus 5. And I've got one last example before I give you a table of methods for factoring polynomials. So this is still example 3, but this time this is D. We're still factoring it completely. So we have p to the 5th minus p. Now they both have p, so we're going to factor out a p. We're going to have p times p to the 4th minus 1. Now we look at step 2 in our factoring steps, and we ask ourselves, do we have a difference of squares? Is there something where we can write it as a squared minus b squared? In this case, I see that we can, because p to the 4th, that's the same as p squared squared. 1 is the same as 1 squared. Because of this, we can now factor further. We're going to bring the original p down, and this can now factor to, remember, the difference of squares factors to a plus b times a minus b. So this is going to factor to p squared plus 1 times p squared minus 1. And actually, this problem's not even done yet because we have another difference of squares. In this third factor, p squared minus 1, that's the same as p squared minus 1 squared. So if we're factoring completely, we're going to have a p. We're going to still have our p squared plus 1 because that's not factorable anymore. But then we're going to also have a p plus 1 and a p minus 1. Once we've done that, we're factored completely. So now I want to give you methods. Now to start on any polynomial, we're going to start by looking for the greatest common factor. A GCF. So for example, if you had something in the form a times b and u minus b times c, we notice both terms have b, so we can take a b out and we'd have an a minus c left within our parentheses. Then if we have binomials, we are going to look for a difference of two squares. For what that means is if we see something and we're able to write it as a squared minus b squared, then it can factor as a plus b times a minus b. Now, trinomials is where we get a little bit more involved. We're going to first look for a perfect square trinomial. And then we're going to look for other factorable trinomials. So, for example, I'm going to give you 4 things to write here. If we have something that looks like we can write it in the pattern a squared plus 2 times a times b plus b squared, it factors to a plus b quantity squared. If we have something that looks like a squared minus 2 times a times b plus b squared, that factors to the quantity a minus b squared. And then for other factorable trinomials, if we see something in the form x squared plus bx plus c, remember that is going to factor to x plus a value times x plus a value. And it might be minus, and the values very well could be different, or will be different even. If we have something in the form ax squared plus bx plus c, remember that's going to factor to very possibly a number times x plus another value times a different number times x, or maybe the same number plus another value. And then a method we haven't talked a lot about yet, and I'm going to want to put an example in here as well, are polynomials with 4 or more terms. And we're going to use a method called factor by grouping. What that looks like is if we have something that can be written as ax plus bx plus ay plus by, we can factor that very uniquely because the first 2 terms have something in common. They have an x. We can take that out. We'd have x times a plus b. And then the other set, so we'd go plus, the other 2 terms have a y in common. So we can take that out, y times a plus b. But now if we look at this, there's still a little bit more that these 2 new parts have in common. They both have an a plus b, so we can factor a plus b out, and we'd be left with x plus y from those terms. I would have loved to have done an example on factoring by grouping, but we just don't have time. So we're done with the lesson.